This is my first of two parts regarding shadows on stairs, and I'll describe how to draw stairs first before I get into the shadows. Remember to subscribe to my channel. An easy way to draw stairs is to start with two parallel right triangles and then connect them with diagonals that are either parallel or converging. And then draw horizontal and vertical lines down the incline. Add more diagonals that are either horizontal or converging, and then finish the stairs with more horizontal and vertical lines. And you can use this as a basis for an organic shape. Here are two ways of drawing stairs in one-point perspective. And we know it's one point because they have true horizontal and vertical lines. In this first case, the risers, which are vertical, and the treads, which are horizontal, have edges that go to the vanishing point on eye level. The handrail and the incline, in this case, are parallel, so they don't converge. In the second case, we again have the edges of the treads and the risers converging toward a vanishing point on eye level, whereas the handrail and the incline go to an uphill vanishing point that's vertically above the level vanishing point because they're connected. Here are two frontal views of stairs, either going up or going down. When they're going up, we see the treads and the risers. The treads get smaller and smaller until at eye level they become a line. These diagonals converge toward a vanishing point on eye level. And the risers we see are composed of true horizontal and vertical lines, and they get smaller with distance. In contrast, when we look at stairs going down, we see only the treads, so there's very little value contrast. And the treads again converge toward a vanishing point, but eye level is well above the picture. And although we don't see vertical lines, we only see horizontal and diagonal lines. We know the vertical lines are hidden in there, and so this is still one-point perspective. It's important to make your proportions correct. So a tread is about 9 to 11 inches, a riser about 7 inches, and a handrail, the post for the handrail, is about 35 inches tall. So this is 5 times the riser. And we can use that information to help. So here is one riser, and I added 4 more. So that would be the top of the handrail, and then it would converge toward an inclined vanishing point above eye level. It's important to make the walls on the side of the stairs horizontal so that they converge toward a vanishing point on eye level. And again, that level vanishing point is vertically below the uphill vanishing point used by the incline. The simplest shadow on stairs is to have a rectangle that aligns with the stairs, because then you have horizontal lines on the treads and vertical lines on the risers. But most of the time that doesn't happen. So here, for example, is front lighting, and the light goes from the front of this pillar to its shadow right here, and it comes down our left shoulder down to the pseudo-sun. And the base of this pillar, the lines on the treads converge toward the shadow vanishing point, so they go in the shadow direction. And on vertical surface, the shadows are vertical because all vertical poles cast vertical shadows on vertical surfaces. We usually only see shadows on the treads because the risers are usually dark. And we have to differentiate between the shade of the step where it's turned away from the light and the shadow that it casts on the next step. So here is the end of this particular step. Let's put a vertical pole between the tread and the next step, and then draw a shadow line like this, and a light ray goes from this corner down to here. To determine which pole casts the shadows on the stairs, find the light ray that goes from the front corner to its shadow on the ground, and that shows you that this whole shadow is cast by the horizontal wall. As a result, we get horizontal converging lines on the treads that go to the same vanishing point as the wall. We also get diagonal shadows on the risers. Now, since this wall is perpendicular to the riser, these diagonal shadows go up to the diagonal vanishing point that I discussed in a previous lecture, which would be vertically above the right vanishing point for the stairs on eye level, and it would be level with the sun. When analyzing stair shadows, see if you can find a point where it seems to change, like right here. And that means that there's a light ray from the front corner down to there. And as a result, this part of the shadow is cast by the vertical pole in front. So we have shadows going in the shadow to the shadow vanishing point on the treads and vertical shadows on the risers. And then the rest of this shadow is cast by this horizontal pole. So the blue lines converge with the pole to a point on eye level, whereas the diagonals on the risers go to the diagonal vanishing point above eye level. I found the shade line on this upright box. The shade line divides the light area from the shade. So it goes vertically up and then horizontally this way, and vertically down. And the shade line is all you need to find the shadow line that divides light from shadow. So let's start with the red vertical pole that casts a horizontal shadow on the ground, which is the shadow direction I chose. The green horizontal line casts horizontal converging lines that go to the same vanishing point as this pole, and a diagonal shadow that goes to the diagonal vanishing point. The purple line back here casts a horizontal converging line that goes to the same vanishing point on eye level, and the final line, this vertical blue pole, casts a horizontal line on the ground because that's the shadow direction I chose, and it has vertical shadows on the risers. To find the shadows of these boxes, start with a light triangle that goes to this intersection here. The shadow goes from the corner to the intersection and then parallel to the casting surface like this. We could extend the surface and draw another light triangle to find this intersection here to complete this shadow. Now, how do we find this point? Well, we would have to, let me do it down here, extend the surface so that we can complete the light triangle and find this intersection down here. Then the shadow goes from this first intersection parallel to the casting surface up here, and when it hits the wall, it goes vertically up until it intersects the light right here, and then it goes to the corner of the box. Now, what about this in back? The easiest solution is just to make it parallel to the casting pole, although we could make this box transparent so we could find the intersection back here that would tell us the direction of this shadow. In the next video, I'll talk more about shadows on stairs.